All right, so B, the altitude of the plane is a function of its time, the time that it is in the air. So let's just do the graph, okay? If I were to do this graph, it would look like this, right? What would be down here? Time. And what would be over here? Altitude. Everyone agree? So when I look up and I see the plane coming into land in Abbotsford, it's up in the air, yes? So at time 0, where would the plane be? Where would it be on this axis? I look out, I'm sitting at the airport, I look up, I see a plane coming into land. I start my stopwatch. Where should I put the dot for where the plane's altitude is? Should it be up here or down here? Up, because it's up in the air, yes? Excellent. Now, I start the time, yes? And I'm talking to the pilot. I time for 1 minute, and the screen goes out. The plane is coming into land in Abbotsford. 1 minute later, I call the pilot and say, what's your altitude? And he reports it to me. Will it be higher or lower than where it is now? Lower, because he's coming into land. Agree? Everybody agree? 2 minutes later, I check again. Where will it be? Lower. Excellent. 3 minutes later, I check again. Where will it be? Lower. 4 minutes later, he's on the ground. Is everybody cool with that? Now, the question is, do I join these points? Do I or don't I? Of course I do. Because even though I didn't ask him at 30 seconds, does he have an altitude? Yes. The plane did not teleport to there, did it? Did it pass through all of these altitudes? And did it pass through all of that time? Even though it's passing through altitudes and times that I cannot measure, it is indeed passing through all of them, isn't it? So for every possible given input of time, no matter how small a fraction I use, that plane has an altitude, doesn't it? Because it never disappears. Do you understand? Prab, you cool? You understand why? Okay. So even though I only have data at certain points, the plane did have to pass through all those points. Cool? Everybody good? All right. Anything else from this page? Going once. Going twice. Going thrice. Sweet. Well, I mean, the answers are right there, of course. So, okay. So let us move on then, cabbages, to the next lesson. I'm not going to quiz you today due to the fact that when I was looking at the quiz, I feel it's a little much to do in a 60-minute block and still do anything else. So I'll give it to you tomorrow. Doesn't matter that it's on a Friday. You know I don't like the test on Friday, but a test is different, right? A quiz doesn't count for nothing. Okay? Just to let you know what you need to study. Also, I was expecting there to be more people gone today, but because today is hair show day, is it not? And it's always kids that are involved in the hair shows. Huh? Maybe he is. Could very well be.
We used to freak out about the volume in the
All right. So I have us here at page 157, linear relations. Okay. So you can see if you read this, and nobody ever reads those, that linear relations are something that we need to be able to explain in many ways. We need to be able to explain them in 4 ways. Words, pairs, table of values, graphs, 5 ways, and equations. Everyone cool? Now we already know a relation is what? Good thing I'm not giving the quiz today. What's a relation? The very first question on the very first quiz from the very first day of notes on this whole unit. What's a relation? No. Thank you. Anytime you compare 2 sets of anything. So, are we comparing 2 sets of anything in this first question? You waited patiently. Extra good thing I didn't do the quiz today, isn't it, Connor? Considering this is now the second question that 30 kids would get wrong. Carlin?
Yeah, you are.
Of course I am. What am I comparing? Cost and number of toppings. Excellent. So this question right here, does it not explain the relation in words? So our very first one is taken care of, isn't it? So there is a relation in words. Right? All right, let's graph that bad boy. If we are going to graph it, we need to decide which one is the independent variable and which one is the dependent variable, don't I? Because the independent variable is going on which axis? X. And the dependent variable is going on which axis? I'm going to reverse those colors because I like to do my independent variables in blue and I like to do my dependent variables in red. Excellent. So, which is the independent variable? Talk with your neighbor for a moment. And bear in mind, this would be a question that would be on your quiz tomorrow. Jordan. The number of toppings is the independent variable. Yes. Why? Emma? Yeah, the more toppings I get, the more I pay. If the toppings change, the cost changes. Right? Okay, so our independent variable is indeed the toppings, and our dependent variable is indeed the cost. So cost, toppings. Now we always get into a big argument here every time I do this question. Cheese counts as a topping. No, it doesn't. Until you put cheese on a pizza, you have bread. Cheese is needed to make it a pizza. So cheese does not count as a topping. So, what is the fewest amount of toppings I can have on this pizza? 0. And then it goes up in what? Numbers. I could have 1 topping, 2 toppings, 3 toppings, 4 toppings, and so on. Will that number realistically end? Of course it will. I could Google the Pan-A-Go menu and find out every single topping you could put on a pizza, and that would be the maximum number I could have here, yes? Now let's be realistic here. Some of the pizza toppings that are available at some places are ludicrous, yes? Pan-A-Go used to offer smoked oysters on their pizzas. Seafood has no place on a pizza, in my mind. But then again, neither does pineapple. And for some strange reason, it's still available. I can't remember what show it was, but in a movie they talked about how Hawaiians have ruined pizza with pineapple. I can't remember what movie it was, but it was a good joke. Pineapple is gross on pizza, Connor. Stop it. Just stop. Pineapple is disgusting. It has no place on a pizza. You know what else Pan-A-Go used to put on a pizza if you wanted? Peaches. Peaches. Oh, ew. Pineapple, yum. Peaches, ew. Whatever. They're both equally stupid. How many of you like a pineapple on your pizza?
It's pizza.
Yeah, you guys like the ham and pineapple there? Barf. See what I mean? We'll never be able to have pizza in this class. Because we'll never agree. Huh? No, I never had peach on a pizza because fruit has no place on a pizza. Now, of course, if you talk to a botanist, there is no differentiation between fruit and vegetables. That's a cook thing. That's why there's all the argument over peppers and tomatoes. It's a vegetable. No, it's a fruit. Botanists don't care. It's a cook thing. And it's so you kids, we can make you kids eat your food. All right, so everybody cool? All right, now, this is where it gets a little bit tricky. If I have 0 toppings on the pizza, what is my cost? $12. You want to put it down at 0 here, don't you? But it's not. It's $12. Is everybody cool with that? And how will our cost go up? Go up by $1.50, right? So the next one's going to be what? $13.50. Then what? $15. Then what? $16.50. Then what? $7.18. Is everybody cool with that? Okay. So, right now I'm 0.12. Is it an open or a closed dot? I've closed it, but I didn't mean to. I wanted to ask the question. Should I open or close that dot? $50-50, guys, at the very least, guess, because I'm going to ask you this question on a test, and you're going to have to guess there if you don't know. Closed dot. Of course it's a closed dot, because it's included. I could pay $12, couldn't I? All right. If I order 1 topping, how much is pizza going to cost me? $13.50. Open or closed dot right there. Closed. Next one. $2.15. 3, $16.50, 4, $18. Does everyone agree? Is there anybody who would like to dispute my graph? Excellent. Next question. Do I join the points based on yesterday? No, of course not. Why? Can't order half a topping. You can say, oh, yes, you can. It says right on the website for Domino's, you can put half it on a pizza. Yes, you can. But they will charge you the full amount. I know, right? I know this because I just had to order pizza from Domino's with mushrooms on half and banana peppers on the other half. Because some people don't like mushrooms on their pizza. And some people don't like banana peppers on their pizza. And I was buying an odd number of pizzas. So I couldn't get whole pizzas. So I do not join the points, yes? Everybody cool? Okay. Does this explain this? Great. So that's the second thing we've done. Now we've done a relation on a graph. And I know it's a relation because I've taken one set of data, toppings, and I've compared it to another set of data, costs. Is everybody cool with that? Excellent. You guys are brilliant. Now, third one was ordered pairs, was it not? Oh, graphs was in the wrong spot. Third one's ordered pairs. Can you guys tell me the ordered pairs that are represented by each of those dots? To do that, you have to remember what an ordered pair is. Who remembers what an ordered pair is? Who finished grade 9 math? Oh, right, all of you. So, what's an ordered pair? I know, grade 9 was a long time ago. Don't be silly. I got time. If only I could remember something to do with graphs and pairs. What could it be? Triple good thing I didn't do the quiz today. I got a lot of coffee and I got a lot of time. Of course it's the two numbers. Excellent. Which one goes first? I don't have X's here. Toppings. What would be a better way to explain it? I happen to be graphing cost and toppings, which means I can use your example to explain one situation, yes? Is math about one situation? No. So what would be a better way to explain what an ordered pair of a linear relation is? Yes, Emma? Yes, we take the independent variable and we compare it to the dependent variable. Excellent. So, what are the ordered pairs of this particular relation? Emma, go. 0, 12. You are on fire, sister. Lexi, look out. What's next? Holy crap. Somebody stop this girl. What's next? 2, 15. Whoo, doggy. 3, 16, 50. And 4, 18. Nicely done. Now, that covers our ordered pairs. How would I make that into a table of values? Which some of you have been taught is called a T-chart. Because it looks like a T. Emma? Oh, wow. 12, 1, 13, 50, 2, 15, 3, 16, 50, 4, 18. Nice. Now we got to do some math. We're finally at the point where we might be doing something new. Although, if you got through grade 9, you should have done this last year. I can't guarantee that you did, of course, because I only taught 2 of you. So, if you were in my class, and 3 of you, if you were in my class in the 9th grade, you know how to do what we're about to do. If you weren't, I can't guarantee it. So, how do I get the dependent variable's value? How do you know what number to put in here? How did you know this was 418? Adding what? I added 150 each time, yes? So I added 150 each time. Agreed? Added 150 to what? How can 4 be 18? 4 150s is only $6. So how did I get up to 18? I had to start somewhere, didn't I? I had to start at 12, yes? So what this is really doing, and I'm going to sort of transition over to the equation part, this table of values is really this, isn't it? And I'm going to change color. Pretend that's a red 0. Pretend I just drew a red T. Except I didn't get a red 0 or a red T. When I put in one topping, do I still pay that $12? Yes. And then I added how much? $1.50, yes? Everyone agree? Okay. When I do 2 toppings, do I still pay that $12? Yeah. Of course I do. But now I add how many toppings? 2. So it's 2 times 150, isn't it? What about 3? Right? What about 4? 4 times 150. Is everybody cool to there? Everybody cool to there? What if I add T toppings? What am I paying? 12 plus 1.50 times T. Does everyone agree? So, what does that tell us if we want to go up to there? What is an equation that will tell me the cost of my pizza? Cost equals what? $12 plus 150 times the toppings. Now you should notice something. The cost is what? The DV or the IV? It's a DV, right? And that equals what? The IV and some math. Every time. Is everybody cool with that? Everybody see how it works? Yeah? Daniel, it's all recorded. You'll be fine. Everybody good? Okay. So now we got to talk about linear relations because they're a special kind of relation. Linear relations are any relation that has a constant change in the dV when the change in IV is constant as well. What does this mean for us? That's the definition, but what does it really mean? It means, and down here, it's not in the box because this is how you remember it. The graph is a straight line, even if it's discrete. So what do I mean by that? I'll let you get that written down for a second, and then we're going to go back up to our graph. When I changed my IV by 1, what happened to my dV? It went up by 1.5, yes? When I changed it by 1 again, what happened to my dV? It went up by 1.5 again. When I changed it by 1, 1.5. 1, 1.5. Does everybody see that? This means that I could carry on this line for how far? Technically. Forever. Eventually I'll run out of toppings. Right? And you can see that it makes this step pattern of rises and runs. Okay? We get a rise. That's in our dV. And we get a run. And that's in our IV. Is everybody cool? Now, we've already talked about that slant, haven't we? It's been given a name early on, yeah? It was the rate of change, right? When the car is going fast, we cover a lot of distance in very little time. When it's almost flat, we cover a lot of time in very little distance. Everybody remembers this? Everyone's good? Okay. So we can all use all 5 things, right? All right, let's turn the page over and see how we're doing with it. Now, I think this page might have printed badly for you guys, or does it look like this? Looks like that? Okay, great. Let's check if my relationship is linear. So the first thing I got to do is I got to check my IV. Is it going up by a constant amount? So the IV is over here, yes? What has it gone up each time? 5. So that's constant, yes? So if this is linear, then all of these changes must be the same. Not necessarily 5, they just have to be the same. So I can get that stair thing going, right? So let's check. 32 to 41 is how far? 9. 41 to 50 is how far? 9. 50 to 59 is how far? 9. Is it linear? Yes. Now I'm going to do something with this that makes kids get this question wrong. Don't write this down, just look. If I erase this one, then the pattern looks different, doesn't it? Right? 5, 10, right? 9, 18. Half of you on your test on this unit are going to get this question, and you're going to say that's nonlinear. Because, well, that one's 5 and that one's 10 and that one's 9 and that one's 18. They're not the same. But they are, aren't they? Because what is half of 10? So if I had data here, it would be 10, wouldn't it? And then half of 18 is 9, and that would be 50. Is everyone cool with that? So if I gave you this, 1, 2, 5, 7, 4, 9. Is that linear? No. But what if it was 4, 11? Is that linear? Yes. Does everybody understand why? Goes up by 1, goes up by 2. Goes up by 2, so that one should go up by 4, and it does. Does everyone get it? All right. Sweet. That makes me so happy. So what does that tell us? In a table of values, it's real easy to check if it's linear, isn't it? What do I have over here? Is that a table of values? Okay, so can I check if it's linear? It's easy peasy. I don't even need to look at it for more than a second to know it's not linear, do I? 555, 75, 2,925. Is that the same? Plus 5, plus 5, plus 5. Looks linear. Plus 75. Might still be linear. Wrong. Can't be. Everybody good? Does everybody feel they could spot a linear relation from a table of values? Everybody. Even if it was fractions or decimals? You still feel good? Okay. So let's move on to talking about an equation. In an equation, it's a little harder. But doesn't an equation give us a table of values? Which of those would you call the input or the independent variable? Y or X? X. What would you call, and so Y is over here, yes? If X is the input, who decides what input is? Who decides what you put in your smoothie in the morning? You do. Who decides what toppings you're going to order on your pizza when you call Domino's? You do. So who decides what numbers I'm going to put in for X? You do. Does it matter what numbers you choose? Not at all. Whenever I do this question, I always use -1, 0, and 1. And some kid always says, Mr. Mars, how did you know to use -1, 0, and 1? Always. Do you guys all see why that's a silly question? Because that's input. I choose what numbers to do there. Could you do 7, 12, and 48? If you wanted to. So, when x is -1, what goes right there? My little red dot didn't follow me. What goes right there? -1. So the y value is 2 times -1 plus 4, isn't it? Which is what? 2. When x is 0, what goes there? So that's 2 times 0 plus 4. What's the answer? 4. And when x is 1, it's 2 times 1 plus 4, isn't it? So what's the answer? 6. I went up by 1, I went up by 2. Is this linear? Yes. How many points must I check to know if it's linear? At least. Why 3? Because 3 is the right answer. Why must I check 3? Aren't any 2 points a straight line from each other? Random points. Are they a straight line from each other? But if it's linear, there would have to be a third one somewhere further on the line, yes? If my third one was up here, is that a linear relation? No. Everybody cool with that? Excellent. So we now know that if we take a linear equation and put it, or if we take an equation and put it into a table of values, we can tell if it's linear or not, yes? Okay, so let's try that over here. What are the points I should use for x and y? Can I tell y points yet? Yes or no? Can I tell y points yet? No, because they're outputs. So what do I choose? Some inputs. Who chooses the inputs? You do. Does it matter what you use? I always use 0 because 0 is an easy one to multiply, right? And I always use 1 because 1's an easy one to multiply. And I always use -1. But you don't have to. You could use anything you want. What do you guys want to use?
2,800.
Okay. Then what? 0.
0.
Excellent. Then what?
Wait, can we make the other 2,800 negative?
Sure.
Can we make that one? Yeah.
Now, what's wrong with Daniel's choices? Are they inputs? Are they okay? Okay, great. So x is 2,800. So what goes right there? 2,800 squared. It's a pretty big number, right? So this is going to be a giant number because it's going to be 2,800 squared times 4 minus 1. So that's going to be a giant number, yes? So I'm going to call that giant y. Is everyone okay with that? Everyone agree? Because I'm too lazy to work it out. What's 0?
0.
So x is 0. What's 0 squared? 0 times 4
0.
minus 1.
0. No,
-1.
-1.
-1. Everyone agree? Okay. What is negative 2,800 squared?
Minuscule y.
No. Negative number squared. It's negative 2,800 times negative 2,800. What is it? Positive giant number, yes? Times 4. Even bigger number, minus 1. It's back to being a giant y, isn't it? So when this went minus 2,800, this went minus giant y, right? Agreed? Then I took away another 2,800. But this time I didn't do minus giant y. What did I do? Plus giant y. Is that a linear relation? Minus 1, plus 1, plus 1, plus 2, plus 2. Minus 2,800, minus 2,800, minus, plus. Is this linear? Plus 1, plus 1, plus 2, plus 2. Minus 2,800, minus 2,800. Minus giant y. So if this was linear, what would this one have to be? Minus giant y. Is it? No, it's plus giant y. So is this one linear? No. This guy's linear. This guy is non-linear. Now, you guys are smart kids, and all you care about is shortcuts. Tell me the shortcut that will allow you to decide if it's linear or if it's non-linear. What's the only difference? Squared. An exponent means non-linear. Because what does that exponent do to negatives? It turns it positive again, doesn't it? Right? Everybody cool? Now, Daniel chose crazy numbers because Daniel's being Daniel, and that's okay. I'm actually glad he did it because it shows that even when you use crazy numbers, you can still prove that it's not right. Yeah. Everyone agree? Is D a linear relation? Is it a straight line? Looks like it. How would we check? You could check with a ruler, or you could check if it makes the stair pattern, yes? Yeah. So from here, if I go up 1, I go almost all the way over to the next one, yes? If I go down 1, do I go almost all the way over to the next one? So does that make the stairs? So if I go down 1, do I go over the same amount? So that's linear. Everybody cool? What about that one? Is that one linear? If I start there and I go there, I went plus 1, yes? How far up did I go? Not at all. So if it's linear, it has to repeat, right? Yeah. So when I do plus 1, how far did I go up? Not at all. Did it repeat? Yep. What about there? Same thing. So is that one linear? Yep. What about 159? Pretty easy. Is it a straight line? This guy? Nope. So he's non-linear. And what's that guy? I start there. Did I make any changes left and right? So I went 0 this way, but I went 1 up. What happened at the next spot? 0 side to side and 1 up. So is it linear? Is the pattern repeating? So it's linear. Is everybody cool? All right, now the last thing we're going to do is we're going to actually graph these things. First of all, before we graph, look at that. Will it make a straight line? Yes, we already know that. Why? Because we already did that question, but why else? No exponent. So if I graph it, who chooses the x and y's? You choose the y's? No, you only choose the x's. What numbers do you want to use? And Daniel, you can't choose. I'm sorry. Unless you help a brother out here.
No, I was going to do a high one again.
Okay. What? Pi. Okay. Does pi work? Would pi work? Sure it would. Can't do it in our heads though. So what would be numbers that would be good to use? I can use -1, 0, and 1. But look at my graph. That's going to be pretty tightly packed, isn't it? So can I choose? The point I'm trying to make here is, can I choose any numbers? Could I choose -3, 0, and +3? I can if I want. I can choose anything I want. Now, on my graph here, even 3s aren't going to work because I don't have enough graph paper here. So let's go 2, 0, -2. When I have 2 for x, what is my y value? Pardon me? 8. When I have 0 for x, what is my y value? 4. When I have -2 for x, what is my y value? 0. Is everyone cool? Does everyone know why that works? You must stop me if you do not understand how we got those pairs. Sweet. So the first dot goes at 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. Where's the next dot go? 0, 1, 2, 3, 4. Where's the next dot go? -2, 0. Does everyone agree? Is everybody cool? Now, the question is it linear? Yeah. Down 4 over 2, down 4 over 2. Cool, it's linear. And we knew it was linear because there's no exponents. Do I connect the line? Is it continuous data? It is. Why? Because I can put any number in for x, can't I? Whatever I put in for x, I can multiply by 2 and add 4, correct? So I'm going to go ahead and I'm going to do something a little weird here. I'm going to do something very weird here. I do. Except it's not working. Because, as usual, it's a piece of crap. Does everyone agree I'm still looking at the same graph? I went up one too far there. Yeah? Now, if we know it's linear, yes? So I'm going to take, and I'm going to go ahead and I'm going to draw a straight line through those points. Does everyone agree that I've drawn my straight line? No, of course not. Because I have a Microsoft product, not an Apple product. Oh, I love my job so much. Let's pretend that's perfect. Okay? Okay. Now, Connor was being a bit of a Weisenheimer, wasn't he? When he said pi, correct? Pi is basically 3.14, yes? Times 2 is basically 6.28, yes? Plus 4 is what? 10 and a bit, right? So if we were to use pi, 1, 2, 3, and a little bit, I should be up at 10 and a little bit, shouldn't I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's on the line. Does everybody understand? What if I chose 10 million? Then I'd be way over there at 10 million, and I would be up 20 million plus 4. And that line would hit it over there. Does everybody understand? Now, and like we just said, can I choose any input here? Yes, because no matter what I choose, I can multiply it by 2 and add 4 and hit the line. Does everybody get it? Now, if I take a point from the line, that should be the next point on the line if it were straight. That point is -4, -4. That's an x, that's a y, correct? So if this is truly a linear equation, then shouldn't -4 and -4 work in here? Okay, what's -4 times 2? -8. What's -8 plus 4? -4, and it does work. Does everybody understand? Yeah? Okay, now I'm going to do one thing here that isn't really part of grade 10. I just want you to see it. X and Y, yes? Is that going to make a line? How do you know? It's got an exponent. So X, Y. I'm going to choose slightly bigger numbers this time because it makes it work better here. 3, 0, and -3. If x is 3, what goes there? What goes there? 3, right? And what is 3 squared? 9. And what is 9? What is 9 minus 3? 6. Now in the middle here, I'm going to throw in 1. What's 1 squared? -3? -2. What's 0 squared? -3? What's -1 squared? +1 minus 3? -2. And what's -3 squared? 9 minus 3? 6. Now, look at what weirdly has happened there. I got a point at 1, 2, 3, 1, 2, 3, 4, 5, 6. Agreed? But I got another point at -3, 6. Weird. I got a point at 1, -2. I got another point at -1, -2. And then I got a final point at 0, -3. And look at the weird shape that makes. That is what we call a parabola. And you will be visiting those a lot next year.
Looks like an ice cream.
Everybody good? Your homework tonight? Now, it looks weird. It looks gigantic, but it's only because there's so much blank space, because there's so many pictures and charts and stuff. It's actually not a lot of work. And as always, the answers are there, and you just need to do a couple. Now, there's this graph didn't work very well, 15. It's very hard to read on my screen. Did it work on your guys's? Didn't print very well. So you probably can't really do 15. 14, it looked like it worked. And the graphs for 5, how are they? How did they print? They're okay? All right, so everybody's got something they can do. And what is happening tomorrow? Quiz on functions and relations. It is 9 multiple choice questions and 1 graph that you need to draw, maybe? I can't totally remember. 2 graphs you need to draw? I can't remember. I'm not doing it today because as soon as I ask you guys to draw graphs for whatever reason, makes the quiz take 30 years. I don't know why. I just say sketch, but people still take forever to do it as soon as I say draw a graph. Okay? Okay.